Start unit testing right away. After this video, I hope when you've watched it that you will see how quick it is, how easy it is, and how beneficial it will be, and I hope you will begin doing it. Since we've gone to a protocol as a solution, we now have the full benefits of being able to unit test or quick actions. And we really should be doing it because it takes a little bit of input, but not a lot, and you get a lot of output out of it. I'll show you an example right here. So I made in a precompile quick action. So it's just a normal protocol here. I just started a protocol, and in the precompile, I have a class called custom path, where there's a method abbreviate path. Now the goal of this method is that it takes in a path separated by backslash, and it will abbreviate the names it finds in that path. So if it finds visuals, it will abbreviate it to V. If it finds customer, it will abbreviate it to C. If it finds protocols, it will abbreviate it to P. So always the first letter of the word. That is the intention of the method, the logic, the code that I wrote. So I have it in here. I try to keep it simple, just a for loop going through a split path and creating a new path and then joining it again. Now, I've written this code, but sure, I could immediately begin using it all over the place. And then while trial and error, I would upload and publish my driver, test it out and see if it works. But that's not a good way of doing it, because if you upload the driver to test it, you do the test, it happens once and that's it. So you cannot recreate the test without updating it and uploading it again. So what you really want to do is test this without needing to upload and without needing to write the code around it. And this is a perfect example, and this is the kind of code you should strive to get. Code that is doing CPU work independent. So there is no dependencies here. I don't even have an SL protocol. I don't have any file system, any reading, nothing is happening. I don't even use a different class. So this is the simplest method possible to test with, and the simplest method to test with is also going to be the most stable. Now, how do I begin testing? It's as simple as right click on the method, and I will say I'd like to create a unit test. You can leave everything here default. Just click OK. Now what it will do is you'll create a quick action 1 test, and it will auto create the necessary properties and attributes you need to indicate that you are doing unit test. There is something also called a test explorer. So when you go to the test under Windows, you can open up the test explorer, and in here you can immediately see that I have a test already. So it created a quick action 1 test, which is the project name, and then it says, okay, the namespace is going to be no dependency tests, and then custom path test. So how do I begin with this? Well, you already get the basic setup, but important for every unit test to remember is arrange, act, assert. Arrange, act, assert. So arrange, act, assert. What does that mean? Well, it's 3 sections of every test that you always want to do, and I've gone into the habit of actually writing in the comments and keeping to that. So arranging means you're going to be setting up what you need to run your test. In my case, it's very simple. I'm going to say var path equals new custom path, because I have a class and I need an instance of my class before I can act, before I can do my abbreviate path test. What else do I need? I need an input, string input path. So an input path, in my case, let's say we'll go with visuals, backslash, customers, backslash, we'll call it, and then in here, let's, for example, say Skyline, and then in there we'll go with protocols, and in there we'll say random name. Sure. So this is just a basic input path. What I'm trying to do here is something called a happy path test. It means I'm going to test something and it's something with a valid input. So the input path is something that would happen in real life. And I'm expecting this to work, of course. So how do I act? Act is nothing but doing path, abbreviate my path and providing it with the input path. Now, this is going to return a result. So I have my arrange is finished. I have my act, it's finished. I have now the result of my abbreviate path. Now I want to assert. Now, what is the thing with assertion is you always want to specify hard-coded in advance what is the expected return. So the expected return, you can actually add that under. So expected path equals, so what am I expecting to get from this? I'm expecting to get v \c \skyline \p and \random name. So this is what I'm expecting to get. Assertions, the basic ones you can do with just assert dot. Anytime you have that, you can do assert dot r equal. You can do that assert is true. There is an assert is false, and so on and so on. So in this case, I'm going to do an assert r equal, and it begins with what is your expected? What do you expect to get out of it? Well, my expected path is what I expect, and what is the actual one? Well, result. Now, a good habit I've gotten into is that I always add an additional message, so a string message after the assert. A lot of books you'll see and a lot of theory will say that for every test you write, you should only have one assert. You may quote me on this, I will call bullshit. You don't. You can make multiple asserts in one method, in one test. The only important thing is that you don't do it too much, like don't have a billion asserts in one method, like keep it on point and make sure you add a message that will make it more clear on what assert exactly failed. So I'm going to just say expected path incorrect. Now, in this case, you could say, well, this feels a bit silly to do because there's only one assert. Yes, but if you have more than one and you've gotten into the habit of writing the message, it will help a lot. So this is pretty much it. So I have finished this. What I always end up doing as well, so the naming convention of tests, it's not a fixed guideline, but really do pay attention to try and at least keep it the same as the other tests that are already in the protocol. So in this case, I'll just say mixed input path, because I have some that need to abbreviate and some that don't need to abbreviate. So I'm abbreviate path test mixed input path. So this is my test. Now technically, so what you can do is you can build and make sure everything builds correctly. Yes, and now if you right click and run this test, boom. So it's already working correctly. What if, for example, imagine there was a problem. So let's go in here and imagine that I forgot to add visuals as one of the abbreviations. If I run this now, the test will fail. So this is also a good example of how you can avoid a different developer making changes to an existing method or class that would break what you expected when you first made it. So I made it in the beginning with visuals. Someone else comes and says, well, there was an issue and I think this is the way to fix it by removing visuals. But they do that and the unit test will break. So having these will make sure that someone doesn't break what you expected. So it now says in the assert equals failed because it expected the VZ Skyline P random name, but it got visuals in Skyline random name, and the message I made was expected path is incorrect. So fixing that by just adding visuals again And if I now run the test, there we go. So that is the easiest test you can do. After this, what you can also do is you can start adding more tests. So what a different one you could do is, for example, well, what if there are no abbreviations at all? Abbreviations, sure. So no abbreviations at all. That means everything here is going to be a random word. Random 3. So, and I'm expecting now to get random 1, random 2, Skyline, random 3, and random name. So now I will test a different thing. I will test what happens if absolutely nothing has to be replaced. So I run this and I'm in luck, it's again correct. However, this could have failed and then I would have noticed, well, okay. But you can see it takes not too much time and it runs super quick. So you can make a couple of these, and once you have one of them, usually it's quite easy to just start adding more of them, like all, or like, for example, empty input. What happens if I provide an empty input? So my input path is empty. Let's run this test and see what happens. So it fails, obviously, but what happened? Did it throw an exception? No, it seems like it failed because it expected my random thing, but it actually got empty. So the current setup is that if I provide an input path that's empty, I get an expected output path that's empty. However, what if that's not what I want? How about I say, well, actually no. If it's empty, I'd like to expect an exception. And you can do that by adding an attribute called expected exception. By adding the attribute expected exception, you can actually say, well, the type of exception that I expect is an invalid argument, or no, an argument exception. So I'm expecting an argument exception from this code. So what does that mean? I don't have an expected path, and the assertion is technically not necessary because there is nothing to assert. What you could always do is just do an assert is true, just to indicate, well, it should just pass this, and if it doesn't throw the exception, it will indicate it as a problem. So if I now run this, it goes an error because it did not throw the expected exception, a system argument exception. So now I can go inside of here and say, well, let's add some validation and throw that exception. So if path, let's try this differently. If string is null or white space, path, what I want to do is throw a new argument exception, and the argument exception is going to be a message with the parameter name. So path cannot be empty, with the name of the parameter, with the name of the argument being path. And now, if this is empty, the path cannot be empty, we should get that argument exception. So if I run my test, it still works. However, you notice I did change something in the abbreviate path. So now I have a battery of 3 tests, so I can run all 3 of them just to make sure I didn't break something else. Because, let me show you an example. What if I was being silly and I did this incorrectly? For example, I just said, I didn't have my if. I just wrote throw new argument exception. So if I run this, the empty input is actually green because, yes, it's correct. I am throwing an exception on an empty input. However, if I run my full battery, you'll notice the other ones are suddenly incorrect because I throw an exception every time. So that's what I mean with it takes a little bit of effort in the beginning, but not a lot. I mean, you can see how quick I did this. And now I have a battery of 3 tests and I feel much more secure much more safe in using this, and I don't need to think about it anymore. So now I can continue developing, and it's like making the foundation of a house and then first checking, is the foundation okay, before you start building more on it. Imagine if the foundation was not alright. Wouldn't it have been good to find that before you built a house on the foundation? It's the same with unit tests. So really begin doing it. It's very easy to do, and especially in these cases. So that's the simplest example, and I really recommend you start doing it.